of all of the integration techniques, I saved this one for last because it's the most special. We've done U sub, we've done change the variable, we've done all these. What this is called trig substitution. And it's kind of a combination of change the variable and U sub. It's kind of a little bit of both. I will give you this help, is that you'll be given what that trig substitution is. You don't have to worry about finding it. So here is this awful integral. What's the derivative of x squared minus 9? 2x. Do we have an x in the numerator? No, we don't. We have an x in the denominator. This won't work with regular U sub. So it looks like a total mess, looks like one we can't solve, but it actually is one that we can solve. And the way that we're going to solve it is we're going to substitute x for 3 secant theta.
Why?
Exactly. Why? Well, it's a form that when you do a lot of integrals, they've found that this is going to work, and I'm going to show you why it's going to work, but it seems to be a little out there. X is 3 secant. The derivative of x with respect to theta is 3 secant the tangent, right? So when we substitute in here, I'm going to do this, square root. Now, x is 3 secant, so we're going to get 3 secant theta squared. Oh, that was not a good idea, because that's not going to fit by any stretch of the imagination. Square root of 3 secant theta squared, and then minus 9. But what's dx? Is it nothing? No, it's this whole thing times 3 secant theta tangent theta d theta. So that's a lot thrown in. All over x, which is 3 secant theta. And you said, why are we using 3 secant theta? Do you see why? What happens to the 3 secant theta in the denominator? It literally cancels with the top. Okay, so then this is going to be 9 secant squared, the square root of 9 secant squared theta minus 1, or 9, and then times tangent theta d theta. And what can I factor out of here? Square root of 9, correct, which is 3. I'm going to put it way out in front here. Square root of secant squared theta minus 1. What is secant squared theta minus 1? Secant squared theta minus 1. Do you remember that? Do you? What's tangent squared plus 1 equal to as an identity? Secant squared. So what's secant squared minus 1? Aha. So it's 3 square root of tangent squared times tangent. And what's the square root of tangent squared? Tangent. And what does this whole thing, unbelievable, simplify to? Tangent squared theta. Now that one's a little tough to integrate, but we can do it. I can just set that there. And then this is going to be 3 change tangent squared into 1, or secant squared minus 1. Secant squared theta minus 1. Yeah. Okay, fill that out. So then this is going to be 3. What's the antiderivative of secant squared? Whose derivative is secant squared? Tangent. And then what's the antiderivative of 1? Theta. And this is going to be plus c. There it is. You're welcome. Huh? I know. We can't integrate tangent squared as it is, so we can change it to secant squared minus 1. Antiderivative of secant squared is tangent minus theta. And then we do have one little thing left. And it's annoying. But we want to turn it back into x. Okay? No big deal. We can do it. It's not the end of the world. We're going to group this so we can get this a little bit more. That was not good. Yeah, something like that. All right, so now we're going back to, remember when we said x was equal to 3 secant? Remember that? X equals 3 secant theta. And we're going to replace theta with x. So this is x over 3 is equal to secant theta. I don't like secant. Do you? Do you like it? I don't like it. Ann doesn't like it. So we're going to rewrite this as the cosine of theta. And that'll do what to x and 3? Flip it. All good? So then you have the inverse cosine of the cosine of theta, inverse cosine of 3 over x. What's the cosine inverse of the cosine of theta? Theta. So now we go back to the problem and we say 3 times the tangent of the cosine inverse of 3 over x minus the cosine inverse of 3 over x. Plus c. There's only one thing we probably should change, and what is that? We do have to make a triangle. We have to make a triangle, unfortunately. All right, so let's do it. Triangle. We'll put theta, cosine inverse, make a triangle. Do. I told you we were going to use that a lot, didn't I? We have used it a lot. It's amazing. It's a song that won't end. All right, so then we go 3 over x, because it's cosine, 3 over x. This will be the square root of x squared minus 9. So we go 3. If you don't mind, I'm just going to multiply this through. 3 times the tangent. So the tangent is opposite square root of x squared minus 9 over what? 3. Minus 3 times the cosine inverse of 3 over x plus c. And this simplifies a little, doesn't it? And there's my... What do you think? Fun. Yes.
So the 3 secant, will you have to multiply by 3 secant of x, or theta times tangent of theta, because that's the derivative of x?
Yes. So going back over the big picture, it's really 2 parts. You got to get down to here first, and that's what we did. And then you have to solve and put this, get rid of theta. So the first thing I did is I gave you x, and x was 3 secant theta. Sounds horrible, but it is. It works. And we got to take the derivative and then substitute in for x and dx. That's what people forget, the dx substitution. And then once we did that and did all the algebra and trigonometric substitutions, we get down to 3 tangent. Then take your x equals 3 secant, solve for theta, which we did, plug that in, and then that's where you get that triangle song, and then that gives you the x squared of x squared minus 9 minus 3 arc. Did I get a minus sign at the end? Yes, got it right. Let's try 2. We're going to do 2. If you can do 2 of these, you'll be ready for the lab and for the cookie. All right, so for this first one, see how far you can get with that.